Hi everyone. At the start of the new year, Kothar has a bunch of new features that have been published to the platform, and today I'd like to go over some key new ones that can help your workflows when performing many body calculations or doing some simple programming in Aleph, and some note-taking as well. So first to start, we have some new changes to our cloud, to our agent system. So before we were able to connect personal agents using Docker and setting it up on your local machines, and you could do this to have to dispense your compute in any way that you would care about. But now we have a new ability to have cloud agents, which are dedicated resources on some clouds that are free for all the users, at least for the interactive one. There's not that many cores. There's a max time limit, so it's to be shared communally, and it's really to help you just get started and run jobs. So I won't go over getting started with jobs. If you would like, we have a welcome to our video here now, which has a little tutorial, and we have our docs and our Discord, so we have a new welcome page as well. For the purposes of this tutorial today, I'll be using the interactive or the shared agent, which is available to everyone, like I just said, and it will be more than suffice to perform the tasks that we need to perform. The second biggest change is we now support Markdown, the Markdown format, and so math typesetting effectively is available along with code typesetting as well in our environment. So you can create a new file if you would like. Just choose the Markdown option, give it a name, and then you go ahead and create it. I've already created one for the moment. And Markdown, for those who are not familiar, is a way to basically take notes. It has a little bit of math typesetting with some standard LaTeX syntax, but it gives you a little bit more than just LaTeX. It allows you to, or math typesetting, I should say. It can, do some basic formatting for you and help divide things. A lot of projects on GitHub or coding related things are done this way. And so what you can do, you can write down some notes or some code, some work that you're working on, and then you can preview it. So if you go to the top right here, we'll have a preview Markdown, and you'll be able to see it here. So it'll open to the side here. You can also preview the Markdown directly by right-clicking here and then just doing Open Preview. It'll just have it directly, but it's nice to see the side-by-side in this case. So we can have different subheadings, titles, subtitles. You can make lists, order them. You can have italics, and you can use bolds. And you can also, now we support rendering images as well in these. So you can actually upload images. Here I found a beautiful picture of an anvil, and it's rendered directly into the Markdown this way. And then, very importantly, what's very nice for all physicists is that we can actually have some math typesetting. It's fairly robust and good, and it's a great way to get started with your workflow. And then you can also add in code blocks. For the moment, we don't have syntax highlighting for everything, but we do support syntax highlighting for Aleph. I'm going to effectively, the Markdown is also becoming a kind of quasi-notebook that we're starting to begin toying with and we're beginning to support, so feedback will be appreciated. But I'm going to preview a way to use the notebook as a way to, or the Markdown I should say, to treat it like a notebook and actually perform calculations, and very importantly, mix it in with our plotting features, which are new, which have been highly requested. So I'm going to close this. And I just want to point out that the inclusion of the image here is a JPEG. You just need to point to the relative path to the image, and you could include it like you would any other Markdown. So I'm going to close this, and I'm going to open up the plotting. So we now support plotting. So what I did is I wrote a Markdown file that actually contains a bunch of code, some simple instructions, and everything that we want to see. So I'm going to open the preview directly, and then we're going to look at the source code after. But effectively, it's a little mini notebook-looking thing where we actually preview a lot of our features. So you can have Aleph syntax highlighting present in code blocks now. So let me just open this as well. I'm actually going to open this as a side, so I'm going to render it again, top up here. And yeah, so we can write some Markdown, and then it can be rendered on the side here. So I'm just going to minimize it for the moment. But the idea is that you can actually edit in real time. So suppose I wanted to change the heading here, plotting 101, how to plot in the workshop. It gets rendered right away, which is very nice. Okay, so our plotting workflow is very similar to other plotting libraries, Plotly, Matplotlib. You make a figure object, you add things to the figure, and then you plot it. you plot it, you save it. So the way that we do it here, very similar, is we make a figure, you add your data to it, your axis labels, you make it pretty, you make it convenient for you to use, and then you save it to a file. Once it's saved to a file, you can actually open the figure, and then you can view it directly into the workshop, or you can put it into a Markdown file like I've done here. So here's an example of a new feature that we have for code blocks for Aleph. So if you write down a code block like I've done here, so I put the code block with the 3 backticks, and then I denote that the syntax highlighting should be Aleph, and then I write Aleph code or valid Aleph code. I could then, in my rendered Markdown, I can actually run this directly. So what I can do is I can go here next to the arrow down here. I can do run, and then it'll show all the agents I have access to. So for example, I have the interactive one that's newly available for everyone to use with limited resources, or I can have my 3 other ones that I have. I'll use the interactive one to show that just how it works. And so I will just click this, and it'll go ahead, I believe. Oh yeah, my tab was, my terminal was lowercase. So it submitted the job, it took 0.6 seconds, yada, yada, yada. And it created figure 1. So in my code here, I asked for figure 1. So I can go to figure 1 here, and I just put in some data. So if I look at the code, all I did is I made a figure, I gave it a title, and I chose in my figure to have a scatter plot. So I use the .scatter method, and then I save it. Very simple. It's very bare bones. It just gets the job done. Just note that these methods are all these methods are chained onto the figure call. So you can just do enter, and then you can start a new line, and you can do it this way. So here I've made this figure. Now I've seen it. So if I want to view it, again, I need to go into my directory where I saved it in plotting fig. I can click on it, and it'll render directly into the workshop. It has some nice animations. Now, we can actually include the figure into our Markdown directly. So here, I write down, let's view the figure. To include the figure in the Markdown, you use the syntax, brackets for the flavor text or the caption, and then in parentheses include the path to the figure. And so here I do this, and you can see that it renders right away in here. Now our style is the Markdown isn't this Markdown style isn't a full notebook yet, so we still don't have access to interactive tracking, and the cells are disconnected here. So this code block is disconnected from this code block as it just executes the job. So they need to be self-contained for the moment, but it's our start at actually getting a full notebook environment. And we can see that the figure here is rendered, but suppose I didn't have it. So if I actually go ahead and delete this, and I'm going to close this again, I need to refresh the rendered Markdown every time. So I'm going to open preview to the side, and it's empty because I can't find the figure. So now if I actually want to go ahead and have this figure be displayed, I need to go down to my dropdown, press run on interactive. It's going to actually generate the figure. And now it still won't update because the way that we've designed this, you just need to go for the moment, open up the figure and check it, or you can also re-preview the Markdown and it should go ahead and go fetch the figure and update it. And then when you go to look at the figure, you'll see that it actually pops up in the way. Now, I can hear already loudly from the back people yelling, being like, hey, a real figure needs axes. That's perfect. We're going to go ahead and provide axis labels to our figure. So rather than regenerating the figure every time, I'm just going to show some ready-made examples, and then I'll move on to some other features of plotting. So here again, we see that we can make this prettier. So what we do is same thing, create a figure, have a title, we'll call it our second figure. Now we're actually going to add axis labels. So you need to give a name to the axis, which is just the label for it. Sorry, the name of the axes. I know this conflicts with matplotlib's syntax at times. Axis labels might mean something else. Axis labels here mean the ticks, so the numbers underneath the axis that give you the gradations. And so you can see I called my x-axis x-axis, my y-axis y-axis, and I want to show the basic ticks here. And then I put my scatter data and I save it. And it's saved in figure 2, so which I can open up, and I can see this here. Again, we're still not quite there because the axis labels or the axis names rather, are in odd places. It's not that clean visually, so we can go a little bit further. So here, what I've done, I can actually make this a little bit bigger, is so another thing, I should mention that our plotting, the way that it works, is that we have a method we have a main figure object and a bunch of methods. The methods input strings at times, or maybe one or two objects. Like for example, the scatter here, it has just, accepts X and Y data in pairs. But really, when you want to start customizing it, which everyone will want to do, you have to pass an option. And in Aleph, we handle our options with option maps. So you can see here that even though I'm here, let's do it like this. So if I go to, we're going to open preview. Sorry, open to the side. We'll see that really what I'm passing is that, and the name is, that was for the wrong one. I apologize. So I'm actually going to indent this, and you can see it should update correctly. Just to make it a little bit clear what the options I'm choosing and to make it less scattered. We pass options. So in this case, you can see that I have my title, I call it my mathy figure. The x-axis, again, name, but now I've actually introduced LaTeX. So we actually support LaTeX rendering or math typesetting in strings on the axes here, which is very nice. So I'm going to say that this is my index, n, and it'll render the n as Markdown, or as math typeset font. And then we're going to change the name location for the axis to be in the middle. And then we're going to choose the axis labels, which are the ticks. We're going to ask to show them. And then we're also going to say, we're also going to want the text itself, the name text style, to actually be a little bit bigger. So we're going to make the font size. So here it's a dictionary. It's not a dictionary. It's a map with an option map. So it's a little bit, it's nested. So it's a little bit confusing. If this is confusing, more documentation can be found in our docs, in the library reference, in plotting. There's only one type in the plotting library. It's just the figure. And the figure has a bunch of methods. And so you can see here, it has a bunch of, there's not that many kinds for the moment, but for each choice, there are many options. So for example, if I go to scatter, which is the scatter plot method, I'm going to have a bunch of options possible, and it's going to tell you what kind of arguments it takes. So for example, if I go to something that says label map, the label option, which is a key for the map, will also have a sub key that asks if you show the label. So in this case, for example, label and then show label, or I should say x-axis, and I will go to name text style. Here we're at font size, everything. Here, name text style. It's a key, but it accepts a map. So here, name text style, it is a key, even though its item or its element is a map. So then this map would index the options for font style, font weight, font family. More on this a little bit later about a trick to potentially browse this as well. But this is the idea, and so I'll repeat the same. I'll make the font a bit bigger. If you are going to use math typesetting in the strings, just make sure you double escape them with 2 backslashes, because or forward slashes, whichever one they are. You want to put one and the other because it's important. Aleph will complain. And then you can scatter, and then we're going to save this, and you can see here that I made this much bigger than this one here. And yeah, so the grid lines are kind of annoying. We're almost there. We can remove them. This is a little bit more particular, but in the x-axis we have these split lines, which are another choice, another option that you can find in the x-axis as well. So if we look for split line, pardon me, this was in the name text style. Name text style, SSS. Name text style, why can I not find it? Name text style. It's a separate one, sorry. Split line. And so we're going to go all the way, split line. And then you can see that there's a bunch of, just show these split lines, which they're not the grid, strictly speaking. And we just turn them off. So we ask them to show false in the X and Y direction. You can keep them if you'd like. And then boom, we have our final figure in this form. I think I repeated this many times. Yes. And then so if you instead wanted this to be a line plot or a bar chart or however you would like it, instead of using scatter, you would use line. So that's the data itself. And so here, for example, I turn this to a line plot, and we can see that it looks this way. And very cool. If you go here, you can see it traces out nicely. Very fancy. Okay, so that's plotting in the Markdown environment. But what could be the case too is you might just want to make a raw Aleph script and you just want to plot it, which is more than fine. So in this case, it's nearly identical. All I do, I'm just writing Aleph code. Here I'm going to, again, indent to make it a little bit clearer what I'm doing. I'm scattering twice. So here I kind of extended all the options, which you don't need to do. So I could, we could make this a little bit more robust, but I will not do it this way. Like so, just so we can see it. Where the axis tick here. So same thing, I'm gonna plot data, I'm gonna give it some options, and I'm going to then do two scatters, so I can just repeat the scatter onto the same figure and mix and match. And I'm also going to put the legend, so I do this for a reason, because when I'm going to run this, now because I just ran it and I'm not displaying it in a Markdown or somewhere, I have to go to the figure directly, which will be the name scatter plot. So I'll go to the scatterplot.figure, and then it'll animate our point. So one thing to notice is that the legend is outside here, so maybe I want the x-axis ticks to be a little bit smaller. Let's say this will be 14. We're going to run it. It's pretty fast. Okay, perfect. Now it's smaller. So what a cool thing we can do is if you want to start looking at data and staring at it and burn a hole in your, with your eyes by just looking at data, you can just select or deselect some data. So for example here, if I deselect the blue data, it actually zooms in and it changes the this data set, whereas if I include it, it actually changes the axes, which is quite nice. Options for messing with the number of data, the markers, the colors, all of that is available and can be seen here in the plotting methods, and you can feel free to play around with them. And you can also message the Discord as well for any questions regarding that. Now let's put the two together a little bit in more detail. So by two, I mean the Markdown and the plotting. So here, let's actually go ahead and use like kind of what would be something that I would send someone on the platform, someone I'm working with, a colleague or another PhD student, a grad student, and I want to send over one file with some code and a way to automate the process so that they can repeat a calculation, just like you would in a notebook. So what I'll do is I will, I have a file here. Let me just go ahead and close these. Okay, so I'm gonna, for the moment, I will just open the preview directly. So okay, so suppose we want to obtain a ground state of some model. In this case, I chose a transverse field icing model with next nearest neighbor interactions. So in my previous video, I showed the way to create models, which is a new class that we have that will automate the creation of operator sums or matrix product operators that we have. And so here what I did is I have a little function that I've used in the last tutorial that just makes the transverse field icing model for me with some certain parameters for j and h and 0.8. This code block, again, I should emphasize, is independent of the next code block that we have. So if you want to link them together, you need to have a bigger code block. But the idea is I've wrote some math. I've then wrote a function that will just create this operator sum for me in form of a model. And then pairing with some previous tutorials that we've done for iterative solvers about obtaining the ground state for something, which you can also see a tutorial here in the tutorials and in the ground state and areas law tutorial. There's some code present here on to do this for other spin models and how you can use iterative eigensolvers to get states that you care about near the end of the spectrum. And yeah, so I'm going to go ahead. I'm going to have this Hamiltonian. I will create a model for it, and then I will have a full code block that I can execute directly. So I have include my function into my code block. In this code block, I make my model, which will have rules that will assemble operator expressions for me. I will then give my system size a number. I will choose an antiferromagnetic coupling, some on-site field. I will make my chain, and then I will convert my model. When I do this function, it returns a model to me, as you can see through this here when I create a model. And it will create the operator sum once I cast it to be so as a real operator sum. Then I'm going to get the low-lying states. I'll get 3. In this case, I'm just going to care about the ground state, but it's It's not a bad idea to get a couple just above the ground state for small systems like this is. Then what I'm going to do is I'm going to create options. I'm going to make sure I'm going to say, hey, my Hamiltonian is indeed Hermitian. My operator, I should say, is Hermitian. It's real. I want the Krylov dimension to be 8, which is the number of my Krylov subspace. More information on that in our tutorials as well. And the numerical tolerance I want for my precision, which is the error that I care about for my solution. Then I'm just going to go ahead, call my iterative eigensolver. I'm going to feed in my Hamiltonian, my operator sum, the dimension of the Hilbert space, the number of eigenvalues, eigenvectors, and eigenvalue pairs that I care about, and then my options. Finally, I just extract my results, which is results 1 will return. So results will return a list of a vector of eigenvalues and a matrix of eigenvectors, in which the eigenvectors are stored as columns of the matrix. Of the second results one. I don't know if that was clear. And then I'm gonna make a list, and basically what I'm gonna do is I'm gonna calculate an observable. So I'm gonna just take the x operator, and I'm going to use our xval function, or it's really a method of an operator, but you can call it this way. And what I'm gonna do is I'm going to take the expectation value in the ground state of x sub n, where n goes from 0 to n minus 1, i.e. goes from site 1 to site n. And I'm going to push this to a list. The reason I'm doing this is for the moment, we don't have a complete pipeline for our data yet. It is coming soon, but saving data and loading data isn't fully clean. So here what I'm doing by printing it is I'm just going to literally copy and paste it, and I'm going to put it directly into my plotting framework, and then I could just plot the data. So here I'm going to do run on interactive. This will take a little bit longer. Not that long though. I've already copied this, but I can go ahead and copy it again. I can just copy paste this, and then I can go into my plotting cell, and so here I chose n is equal to 16. This is me pasting in the data. It's already been there. I create my sites, my indices, and then I go ahead and make my figure how I care about. Add a legend there if I want. I don't need to do this. Oh, sorry, I cannot do that. Let's go here, and let's just take off this here, as there's only one data stream. Oh, spoilers. And then I'm going to go ahead and just run this. So I'm just going to go ahead and run on interactive. I'm going to go over here. It doesn't take very long. Now, I've already rendered this one time, but again, you would click figure, and the data would appear here. And so that was a summary of our new features regarding plotting. If you have any questions, please put them in the Discord chat in the help us section. It'll be greatly appreciated, and that's where you can reach us the fastest, and we'll have someone watching all the time. Thank you much for your attention.